Good morning, everybody. Can you hear me?
Good morning,
Yes.
yes.
Thank
Yeah.
you. Thank you. All right. Okay. Hope you had hope you had a good break on Monday. I know some people logged in for the Zoom course, but at least they didn't drive to campus and have to sit in an empty parking lot. I've seen students do that before. All right. Let's have a look. What are we doing? I wanted to look at the schedule here, make sure we were on track. Yeah, I think I had started on module 3, and I think we're at module 4 now. So hopefully, I haven't checked, but I'm hoping that people have done some stuff with modules 1, 2, and 3, because you can up to this point. Did anybody have any other module 3 related questions? Actually, I don't know if I went through the homework. I didn't go through the homework, did I? Module 3? No, I don't think so. All right. Okay, so let's look at the module 3 assignment here. Not incredibly difficult. So the idea here is that you do a matching type thing here. So we know that the 1 meter goes on the bottom, so it'll be number 2. 100 centimeter goes on top. So it's not incredibly difficult. When you get to something that's got 2 steps in it, like this one, then you use the other things that we've talked about with dimensional analysis. So we know that the number 2 here will be the 100 centimeters, so centimeters cancel. We know that number 3 will be kilometers, because that's what we need at the end. Then we just had to figure out what 1 and 4 are, and we're looking for something that relates to those. They're both going to be meters, but 1 meter is 100 centimeters, so we know that's number 1. And number 4 would be 1,000 meters, because that's 1 kilometer. And that's all you would do. So that's how you would complete assignment 3, or module 3 assignment. Anybody have any questions so far?
I have one question.
Yeah.
So are the sorry, my brain's not working.
That's right.
The formulas to get from, like, I know for the metric scale it's not hard, but like imperial formulas, will those be in the test?
Yeah, you'll be given them.
All right, thank you.
Just a reminder, I know there's people here who don't have their video on, and it's one of my syllabus requirements that you have your video on. So please, I'm asking you to turn your video on. If you can't, you need to be sending me an email to saying why you can't have your video on. But I've noticed that people tend to be a bit more engaged if they think I'm watching them. I don't know, just one of those things. I mean, think about sitting in a classroom. If you would do half the things that you would do while not having your video on a Zoom session. So there's still a few people here that haven't put their video on, and I'm hoping I'm not going to have to talk to them further. I'm noting down names right now. Ruby, I don't know who this is. All right, thank you. You see her? Yeah, sometimes I wonder if people are even watching, if I'm not getting any response from them either. All right, so that's just a reminder. Thank you. I'll take note. All right, so that's the Module 3 assignment. Now remember that all the assignments have video tutorials for them. So when we look at Module 3 measurement here, there's the assignment problems, and you can see that there's a video link to all of the different assignment problems here. So if you're having trouble with the assignment, you can always go look at that. Then you've got the Module 3 practice. So for this one, you'll use the conversion charts that are in the survival guide. And for this, what you'll do is you'll type in what goes in 1 and 2 exactly, and 3, of course, which is the answer. I'm trying to think. You see, I'm teaching this intro to chem class as well. I know I went through temperature conversions. Actually, I think I went through temperature conversions with you all, like, and talked about the significant figures with that. So just that's something to be aware of as well when you're doing these, making sure you're getting significant figures right. Sometimes what's going to happen is you'll type in an answer, it'll get a check mark, but you'll get less points for it. And the reason that you get a check mark but less points is because the significant figures are wrong. So just keep that in mind as well when you're going through and getting the answers here. I know I'll get more than one email from people about why they're not getting full points on their answers, and that'll be the reason. So the credit quiz is going to be pretty much the same as the practice quiz, at least in formatting, and it'll be different questions each time, but you'll get 2 attempts at the credit quiz. You have unlimited attempts at the practice quiz. Does anybody have any questions? Any other questions about Module 3? Any other questions about Module 3? If you're worried about formatting for the practice quiz, and you're wondering, well, what kind of formatting am I going to want? One thing you can do is simply go to the practice quiz and submit it blank, and then look at the answers, and that'll give you an idea. Yeah, let me show you that. It's just reminded me when I was doing it. I'm going to do that now. So you can see what happens here if you just submit it blank. You're welcome to do that. I don't have a problem with it. You might want to do that first if you're not certain about the format that I want, spaces and units and that kind of thing. So you just submit it blank, and then it shows you the answers here. I want you to realize that the answers are whatever's in the parentheses, and when there's something separated by a comma, either of those answers would be acceptable. Right, so remember that the parentheses aren't part of the answer. I've had people actually cut and paste these into their into the slots and wonder why the answers were wrong. Well, they were including parentheses or the entire answers here, which is kind of strange, but that's what happens. Okay, any questions at all? Anybody uncomfortable with the material thus far? I hope not. Okay. Well, let's move on to Module 4 then. And what we're looking at here is density. for this module. So it's not a particularly difficult module. And what we're going to be looking at is how we manipulate the density equation, which I think most people are definitely aware of here. Just fixing my cables here. All right. So density is mass divided by volume. And that means that volume is mass divided by density. And we also know that mass is density times volume. So the definition of density is grams over milliliters or cubic centimeters. Now, a milliliter and a cubic centimeter are pretty much the same thing. I mean, if you take a milliliter of water, it would fit into a cube that is 1 centimeter by 1 centimeter by 1 centimeter, which is a volume of 1 cubic centimeter. 1 centimeters times 1 centimeters times 1 centimeters. So that's where that comes into play. Now, generally, milliliters will be used for liquids, and cubic centimeters will generally be more for solids, although they are pretty much interchangeable. But you'll notice a bit more consistency that way if you look at what you're actually talking about. So we talk about density, and density is mass per unit volume, grams per 1 milliliter. How many grams 1 milliliter of something weighs is what density is. We also talk about specific gravity, which is the density when compared to the density of water. And the unit for specific gravity is no unit. So it's basically density divided by 1 gram per mil, which would come out to the same number as density, just without a unit. And I think, excuse me, sorry. I think you're all aware of the formulas for the volume of a cube, which is side cubed, and the volume of a rectangular prism or block, which is length times width times height. Does anybody have any questions so far? So just starting out with something very simplistic, if we want to find the density of something that it had 100.0 grams mass, 20.0 mils, we would just apply the formula. And the main thing we have to be wary of here is the significant figures. So 100.0 grams has 4 significant figures, 20.0 has 3. So our answer comes out to 3. That's why it's 5.00 grams per mil. You'll notice that we do grams per mil because that was the unit we were given, and it seems like we're dealing with a liquid here. The specific gravity would just be 5.00, so it's 5.00 grams per mil divided by 1 gram per mil, which is just 5.00. Anybody have any questions so far? So this is complete multiplication division. So it goes by number of places passed, it goes by number of significant figures to get the significant figures in the answer. We can manipulate the equation and figure out mass by doing density times volume. The little word of warning here, in the assignment, density times volume could go either way. It could be volume times density or density times volume. And what I've done in the assignment is I've actually set it up so one of them is already set, so there's no confusion as to what goes where when you're doing the assignment. So just keep that in mind. I'll try and show you an example of that at the end here. But just be aware it could be density times volume or volume times density. And again, the significant figures, it's all multiplication division. This is 4 significant figures. The other one is 2 significant figures, so the answer comes out to be 2 significant figures. If you put it in your calculator, it comes out to 3618 grams. But if we want two significant figures, it becomes 3600 grams or 3.6 times 10 to the 3 grams. So either way of expressing that is going to be okay. Does anybody have any questions? I think you're beginning to see that with this particular module, it's not so much the equations or the math that's going to be problematic. It's going to be the significant figures. And we can also do a calculation for volume, which is going to be mass divided by density. You'll notice that we always include the units here. The grams will cancel, the mils will go on to the top here. And again, we've got 3 sig figs, 3 sig figs, so the answer comes out to be 3 sig figs here as well. Any questions so far? Okay. All right, so moving on to something where we're dealing with a cube or a rectangular block here. And what that requires is if we know what the side of the cube is, then we can figure out what the volume is. You'll notice that we don't take significant figures into account here until the very end. And the reason for that is because throughout this problem, we're dealing with multiplication and division all the way through. So the volume of the cube will be figured out with all the available significant figures, and then we use that in the density equation in order to obtain the density. So what happens is that we've got 2.1 times 2.1 times 2.1. That's how we get the 9.261 here. We look at the initial problem and we can see that we've got 2 significant figures versus 3 significant figures. So the answer comes out to be 2 significant figures at the end. And again, it's all because we're dealing with multiplication and division all the way through this problem. Does anybody have any questions? Similar problem here. Here we've got a rectangular block. Again, to get the significant figures, we go back to the problem and we look for what has the least significant figures. We've got 2, 3, 3, and 3. So the answer comes out to be 2. So that will be 2 significant figures. That's where the 0.94 comes into play. Does anybody have any questions? Okay, things change a bit when we have a different kind of problem now that involves the mixing of operations. So we're going to deal with the subtraction and we're going to deal with the division. And this is where things could start to get confusing and annoying for students. So let's take a look at how that will go. The nature of this kind of problem, let me move it back here. All right, is that we've got a graduated cylinder, not a very good graduated cylinder, and it's going to have a certain amount of water in it. In this case, it's 12.3 mils. Excuse me. And then we've got a stone, which is an irregularly shaped object, which is going to go into the graduated cylinder. And of course, what's going to happen is the water will be displaced and it will have a new volume. Now, don't ask me why this is, but for some reason, this particular graduated cylinder seems a bit faulty. It has looks like it can be measured to 1 decimal place in one part, but no decimal places on the other part. So one part of it's more accurate than the other. This affects the accuracy of the volume that we're going to get. Now, the volume of the stone is pretty obvious. So the volume of the stone is going to be 15 mils. minus 12.3 mils, which comes out to be 3 mils. Now what we're dealing with here is a 1 decimal place difference. So this is 0 decimal places, this is 1 decimal place. So the answer comes out to be 0 decimal places. I have no choice but to use that in the next part. That's where the 6.34 grams divided by 3 mils comes into play. So we're mixing operations here. That's the difference between this example and the previous one. So you'll notice that in the previous example, we'll go back to that. To get to significant figures, I went back to the problem because it was all multiplication division. That has 2 significant figures, so the answer has 2 significant figures at the end. And I don't take any significant figures into account until the very end. But for this kind of problem that involves a subtraction, I have to get the result of the subtraction first and then use that in the multiplication division, which is why we only end up with 1 significant figure at the end. Does anybody have any questions? All right. Is Sarah, are you there? Hello? The other kind of problem that's related to this, oops, went too far here, is when we're trying to get the density of a liquid. And one way we can do that is we can have an empty graduated cylinder, and then we put a volume of liquid in there, and the mass is going to be the difference between the empty graduated cylinder and the full graduated cylinder, and then we'll also have a volume as well. So for this one, it's a similar situation as what we had previously. The mass of the liquid is going to be full minus empty. It's going to be 175.05 minus 150.0, but look at the difference in the decimal places here. One is 2 decimal places, the other one's 1 decimal place, which means the answer comes out to 1 decimal place as well. And then we take the 3 significant figures here that we get, and we use that as the mass and divide it by the volume that's in the problem, and that will come out to be 3 significant figures. Does anybody have any questions? All right. I'm actually going to, let's see if I can remove, there we go. Since I can't get an answer from this person, I'm going to remove them. If I can. Nope. Doesn't look like I can remove them. All right. I'll have to take other action. All right.
There might be a way.
It doesn't matter, Joseph.
Yeah. Okay.
Sorry. It's all right. I'll figure it out later. Well, that's pretty much it for density, really. I mean, those are the hardest things to deal with. Let's take a look at the other bits of it here. So you should be able to now do the Module 4 assignment, the Module 4 practice quiz, but let's have a look at the assignment here. Now, in this instance with my courses, it's not enough. If you don't use an answer, you actually have to put this in. So let's see what this one would be. So this was, it says 1.25 kilograms. That needs to be converted into grams. So we're talking about this being number 1, this being number 2, and this being number 3. So I have to put the 3 in there. I can't get away with not putting the 3 in there, even if I'm not using the answer. With this one, this is one where I was talking about earlier, when you have to find the mass, and it's density times volume, or volume times density. And you'll see here that 1 has actually already been set to something. And the 1 here, you can see is 1 is already 200.0 mils. So that's going to be 1, which means that that's the volume, and then the density will be number 2. So just keep that in mind, that 1 has already been set here in this question. Just read the question, you'll see it. And the 3, of course, will go in the unused answer. Another thing you'll see is that you got these, when you got some of the same, you need to put them in numerical order when you're doing the assignment. And for length and width times height, you can see that those are already set for you as well. So just keep that in mind too. All right, does anybody have any questions about the assignment?
I have one.
Yes.
And what do you mean by numerical order? Does it mean like one answer then another answer?
Well, for example, let's go take a look at this one I was looking at. This one here. See how there's 3 instances of 12.4 centimeters here.
Yeah.
So the this would be the one that's used first, and then the number 2 would be used second, then the 3 would be used third. And okay, you'll notice that there's 2 instances of 36.6 cubic centimeters here as well. So the first one you see would be number 1, the second one you'll see would be number 2. Now you can do that when you're doing the, I mean, I'll go through it if you'd like. Let's have a look. We got the time here. So the density, so the volume here will be 12.4 cm times 12.4 centimeters times 12.4 centimeters. And that's going to come out to be actually 1906.624 cubic centimeters. And then we'll do the density is equal to mass divided by volume. And the mass here is 98.40 grams, I think. Divided by the volume, 1906.624 cubic centimeters. Which is going to come out to be an answer in grams per cubic centimeter. And what I'm looking at here is a number, we've got 12.4 centimeters 3 times. So I would say that this will be number 1, this will be number 2, this will be number 3. So they have to be put in the right order. And then we've got, if you look at the thing, we've got 1 instance of 1906.624. So that's going to be number 4. You can see up here, see that equals the density we get. That's number 1. So that'll be 4. And then we've got the mass, which is number 5. And then number 6 will be the second instance of the volume. So number 2 here. And then we have the answer, which should be, well, actually, the answer is already given. So the rest of these would be unused answers, and those you would put 7s in. And that's how you would complete that. Is that okay?
Yeah, thank you.
Yeah, no worries. Does anybody have any other questions? Okay. I don't think it's going to be a real challenge for folks. Okay. Okay, so going back to module 4, we've got the module 4 practice here. And it's going to follow a similar pattern to what we saw with module 3. And again, it's just writing in the answers here. Now, you've got this 50.00 grams. If you were to write just 50 grams instead, you'd get that wrong. And that's because 50 grams and 50.00 grams are two different animals. So 50 grams does not equal 50.00 grams. And the reason for that has to again do with significant figures. Because 50 grams is some number that lies between 45 and 54, whereas 50.00 grams lies somewhere between 50.004 and 49.995. So you can see that one number is much more accurate than the other. So I do get some pushback occasionally from students who say it's unreasonable for me to say, well, look, it says 50, it's the same as 50.00, it isn't. So just be aware of that. Anybody have any questions?
I do.
Yes, Joseph.
Could you please show us where? Could you please show us where?
I'm sorry, Joseph. I can't hear you.
Was I muted the whole time?
No, not the whole time. It just came out. Okay, so what's up, Joseph?
You're muted.
I shouldn't be muting. Hang on. No, I'm all right.
Okay, my whole Zoom glitched. Sorry.
Okay.
Can you show us where the transition formulas are for Fahrenheit and all that for module 3? I was just trying to look through it.
Oh, okay. All right. So they're in. Let me get out of here. While you're doing the homework, I'm going to show you two things here, actually. While you're doing the homework, you should consider it to be open book. I'm expecting people will have it open. And in the Module 3 PDF or the Module 3 soft chalk, either one, on page 2, you'll see the conversions here. You'll also see the temperature conversions are down here on the bottom on page 2.
Thank you.
Now, the other thing, when you're doing the test, you won't need the conversion tables in front of you because I've included the tables within the test. So if you look at the module 3 tables, here they are, along with the temperature conversions. Do you see that, Joseph?
Yes, thank you.
Okay. So again, the homework I'm expecting to be open book, which means you're going to be able to access the conversion charts from the module. And if you're doing the test, then you would be expected to not have any materials in front of you, just use the materials I've put within the test, and you should be good. Okay, does anybody have any questions? Anybody have any questions? Okay. Well, I know we're a little bit ahead of schedule here, so I'm actually going to start a bit on Module 5. This is the bane of most students' existence when it comes to intro chemistry, is actually these two modules, modules 5 and 6. They're the ones that seem to be the most challenging of any of them. So we're looking here at formulas and compounds. And I know that a lot of people find this really challenging, but I'm hoping that, you know, once you see it now, it'll be less challenging than it was in the past. I know you've all seen this before, and some of you had varying success with being able to do this successfully. So our idea here is that we're going to look at how we name these different things. So let's look first of all at, here's my, all right. Here we go. So if we look at the periodic table, there's certain things that we can immediately see because we know something about the valence electrons for certain groups in the periodic table. And we know that in group 1 and group 2, we're looking at +1 and +2. Aluminum is +3. And then over on the other side, we've got -1, -2, and -3. So that's the first thing that I would be aware of here, is that we have already got some charges set here. So group 1 is +1, group 2 is +2, and aluminum is +3. Now there are other things in the aluminum group, but we only really talk about aluminum in that group as being one of these. We also know that group 7 is -1, group 6 is -2, and nitrogen is -3. So you can see that based on how many electrons these things need to lose or gain in order to get their octet, which is something we've talked about before. And this is just going to be base knowledge that we're going to need for this module. The +1, +2, and the aluminum being +3, these are set charges. These do not change. And this has an effect on how we name compounds that involve these kinds of elements. We call these the type 1 cations. Okay, thank you. We call these the type 1 cations. And that means that they don't change. The other ones that are in the middle, we call them type 2 cations because type 2 cations can have more than one charge. And this has an effect on how we name them as well. Does anybody have any questions so far? We also have to deal with what we call polyatomic ions, which are these guys here that have more than one element in them. And again, this is something you don't have to memorize. You're given the sheet in any test that you'll be given, and you'll be able to figure out the structures and names based on that sheet. So I talk about the type 1 cations, and type 1 cations are always the ones in group 1, group 2, and aluminum. Does anybody have any questions about what I mean by group 1 and group 2?
Yeah, I have it.
Yeah, okay. So what's your question, Carlos?
So like, is group 1 like for like hydrogen and lithium and?
Yeah. Mm-hmm. Group 2 is the one with beryllium, magnesium, and here aluminum is the only one we talk about in group 3. So that one's +3.
Thank you.
Okay. So you'll notice that if we were to take NaCl and name it, it would be sodium, and then it would be chloride. So the first part of the name is just going to be the metal, and the second part of the name is going to be the anion with IDE at the end. So root name plus IDE. But you'll notice when we look at the name, you'll notice there's no Roman numerals at all in here. And that's what's important. So the type 1s don't change, and this is really important, I think. No Roman numerals. The type 2s, which have more than one charge, will have Roman numerals. So if you look at the names here, even for something like Al2O3, it's just going to be aluminum oxide. Now, you might be looking at that name and think, well, how would you know that there were two aluminums there if we were to take this name and write it back as a formula? Well, all of what we do here is really predicated on one thing, and that is that the positives and the negatives always even out. So if you've got aluminum oxide and you've got the name of it, and you wanted to come back to the actual formula, what you would do is it all comes back to the charge. Aluminum has a 3+ charge, and we know that because it's one that is already set. Oxide is oxygen with a -2 charge. And then what we've got to do is come up with a way to make these even out. Now, obviously, if you had one of each, that's not going to work. +3 and -2 won't balance out. However, if we were to have 2 aluminums and 3 oxygens, that would mean that we've got +6 and -6, which means that the formula would be Al2O3. And that's the whole point of what we're trying to do, is we're trying to be able to come up with names for formulas and then formulas from names as well. But they've got to be self-consistent and they've got to be unique. You can imagine how difficult it would be if there were 15 people in the class named Smith, or even Charles Smith, for example. I mean, how would I know who was who? But in the case of these kinds of things, the formula and the names have to match, and they have to match uniquely. Does anybody have any questions so far? Let's look at some examples with type 2 cations. I've already pointed out that these are going to have Roman numerals, and the Roman numeral is always going to match the charge on one of them. We'll say charge on each cation. That's important. The word each is important there. So if we had something like CuBr2, what I would do is draw a picture of it, because at this point I don't know what the charge on the copper is. And the reason is because it's not one of these. It's not in group 1, it's not in group 2, it's not aluminum. So I have to figure out what the charge on the copper is so I can name it correctly. So we know that each Br has a -1 charge, which means that the total is -2. In order to make this match, that has to be +2, which means copper has to be +2 as well. So we do this kind of progression here from the negative side over to the positive side, and then we can name it. And it's going to be copper 2 bromide. Does anybody have any questions? Okay, let's look at another example here. Let's see this one here, SnS2. Oops. And if I did a picture of this, it would look like Sn and then 2 S's. Now for this one, you might try and be smart about it and say, well, you know, that's just going to have a 2+ charge because that's a 2, but that one doesn't work like that. We need to know the charges on each one, which comes out to be -2, which means that that's going to be +4, which means the Sn is +4 as well. So the name for this would be 10,4-sulfide. And the 4 here is from the charge on the 10. Does anybody have any questions? This will always be the way you'll do it. You'll always figure out the charge on the negative side, figure out what matches on the positive side, and then go from there. All right. Let's see, chromium, we'll do chromium Cr3, no, I won't do that. Yeah, Cr3 and 2, yeah, we'll do that. So we'll name this one, and again, we draw a picture. It's going to be 3 chromiums, 2 nitrogens. For nitrogen's -3, which means that's -6, which means the chromiums are +6. Then I have to split up the charge between the 3 chromiums. So that's 2+, 2+, and 2+. So the name of this becomes chromium, not 6, but chromium 2 nitride. Does anybody have any questions? Nobody has any questions. That's hard to believe. Everybody's hunky-dory, huh? All right.
I have one quick question, actually.
Yes, Joseph. Yeah.
Is the naming chart, I don't know if you have the naming chart in your, I remember some last classes where we had naming.
This one? The polyatomic ion sheet? This one?
No, it was a chart. I think I might still have a picture of it on my phone. I might email it if you don't have it. It was a naming chart like that actually had like, oh, is it a non-metal or a metal?
It's like a flow chart.
Yeah, it was a flow chart.
Yeah.
Made it really easy to memorize, but.
Well, I'm hoping it's not really so much about memorization as it is about understanding that the negatives and positives have to even out, and why we use Roman numerals sometimes and don't use Roman numerals at other times.
Okay. Yeah. No, I get that. I was just wondering
I mean, that's the focus. That's what I'm trying to get you to do. I'm not real fond of using a flow chart because I think it's a crutch and it oversimplifies things.
Okay.
All right, let's look at some examples that have polyatomic ions. And yeah, that brings me to an important point that I'm going to go through here. So I'm going to do two examples with the polyatomic ions. We'll do Na2CO3 and we'll do Cu. No, I'll do that. I'll do Cu MnO4 2. So we start out with the Na2CO3, and well, maybe that's not a good example. I might do, I'm going to cross that out. I'm going to do Cu2CO3. That'll be better. And if I drew a picture of that, this is what it would look like. Now, sometimes people get confused with this CO3 here and they're thinking, oh, okay, that means there's 3 COs or something like that. There's only one CO3. Can anybody tell me how you'd know if there was more than one of a polyatomic ion?
There'd be a parentheses around it.
Yeah, that's right. There'll be parentheses on the outside of it. So if you've got CO3, you've got to assume there's only one CO3. The charge on CO3 is -2, and we know that from the polyatomic ion sheet. And you can see it there at the top, CO3 -2. And if that's -2, then the charge on each of these coppers is going to be 1+. So it brings it up to +2. So that would be copper 1 carbonate. No, I'm going to run out of room on that. So copper 1 carbonate. Now, yeah, I know there's 2 coppers here, but the 1 doesn't represent how many coppers there are. It represents the charge on each copper. I think that's important. So I know I can always tell when people understand and don't understand, because they'll name this as copper 2 because there's 2 coppers, and that's the way they understand it. But it's got to do with the charge on each copper. So it's copper 1 carbonate. Does anybody have any questions? So again, making that distinction. Making that distinction between how many of a polyatomic ion group there are is going to be important. So we've got Cu MnO4, and there are two MnO4 groups because we've got the parentheses there on the outside. MnO4, as you can see up here, is at the top. MnO4 is a -1 charge. There's two of them. So that's -2, which makes the positive side +2, which means the copper is +2. So the name of that would be copper 2 permanganate. And again, we just get that name directly off the polyatomic ion sheet. There's no need to memorize anything. It's right there in front of you. Okay, does anybody have any questions? Anybody have any questions at all? All right, I think that's a good place to leave it for today. And we will continue with this on Monday. In the meantime, you should be doing the homework and you should be getting up to module 4 by the time we have class on Monday. If you want to leave stuff to the last minute, well, that's your prerogative, but it's also the risk that you'll take as well. And I won't be particularly kind to people who say they've had some sort of last minute emergency and couldn't do the work, because you've had so much time to get this done. All right, does anybody have anything else? Any other questions?
I have one, but it's related to a test. So I don't know if you want to wait for the whole class or we can do it privately.
We can do. Why don't we do it? Why don't we do it? We'll do it now. I mean, but not.
Okay.
But I mean, I'll talk to you as the class is leaving.
Yeah, let anyone else who has a question go first. It's not that important.
Okay. Does anybody else have any other questions? Okay. All right, Joe. Looks like nobody else is asking a question, so you're more than welcome to look. Anybody else can leave if they want to. So what's your question?
Oh, wait. Never mind. I have completely solved my own issue looking through my own notes. I was going to ask a question about bonding, the types of different bonding, but then I realized it was not the electronegativities. It was the type of the atom.
Okay.
That's me. Thank you.
All right, no worries. Thanks, Code. All right, thanks, everybody. I'll see you all later.
See you Wednesday.
Thank you, Professor.
Thank you, Professor.
Thank you.
Yeah, Monday. Bye.
Bye.
Bye. All right, thanks, everybody. Morgan, can I help you at all?
No, I'm good. I'm just leaving right now.
Okay, fair enough. Just checking. Cheers.